So in chapter 3, we're going to be looking at ionic bonding and simple ionic compounds. We begin by looking at the different types of chemical bonding with a particular focus on a class of bonding called ionic bonding. So atoms will come together to form a chemical bond, which is a very strong attraction between atoms. When they do this, the electrons on different atoms will interact with each other, and the reason for the chemical bond forming is so that we end up with a more stable arrangement than when the atoms are not bonded to each other. So in order to understand why chemical bonds form, we should really be thinking about what causes a more stable arrangement of the atoms when they're bonded rather than when they remain as individual atoms. So a good place to begin in understanding this is to think about what atoms on the periodic table are the most stable or the least likely to react elements. And these are the elements that are in group 8A, which we call the noble gases. And if we look at the electron configuration of these atoms, what we realize is that they all have a complete outer shell, which in the case of helium gives them 2 electrons in their outer shell, and for all of the other noble gases will result in them having 8 electrons in their outermost shell. So what we can conclude is that the most stable electron configuration, the one in which atoms don't want to change, is when our atom has a completely filled up outer S and P subshell. That is, that their electron configuration ends with NS2 NP6, where N represents the number of the highest shell. So if an atoms don't have that stable electron configuration, that is that they are not a noble gas, then how they're going to get it is through forming chemical bonds. So this is often summarized by what's referred to as the octet rule, which says in forming chemical compounds, atoms of elements either lose, gain, or share electrons so as to obtain a noble gas electron configurations of the atoms involved. So there are 2 ways to satisfy the octet rule. One is through losing and gaining electrons, that is to form what we call ionic bonds, and that's the subject of this chapter. And then the other is to share electrons and form what we call covalent bonds, and that's the subject of chapter 4. So when we think about an atom, a neutral atom, it's important to recognize that they have an equal number of electrons and protons because they have no overall charge. They are electrically neutral. If an atom loses or gains electrons, then there will be an imbalance in the number of protons and electrons, and a charged species called an ion will form. Now, if an atom loses 1 or more electrons, it will form a positively charged ion, which we call a cation. So for example, sodium has 11 protons and 11 electrons. If it loses 1 electron, it will now have an overall +1 charge because it has 1 more protons than electrons. And so it will form this sodium +1 cation. And note how we indicate the charge as a superscript. And if there was more than 1 positive charge, we would write a number in front of the plus sign. So the elements that we observe to form positive ions or cations are hydrogen and the metals, those elements that are to the left of the staircase line. So you can remember that cations are positive by thinking about cations being positive, because they are cations, right? Okay, cool. If an atom gains one or more electrons, it will form a negatively charged ion that we call an anion. So for example, chlorine, the neutral atom, has 17 protons and 17 electrons. If it gains one electron, it will now have 17 protons and 18 electrons. And because it has an excess of electrons, it will now have a negative charge. And again, you can see that we indicate a single negative charge by putting a minus sign as a superscript following the atom symbol. If we had multiple negative charges on our ion, we would put a number before the minus sign. So the elements that form anions are the nonmetals. Those are the elements that are to the right of the staircase line. And I always remember that anions are negative because the first three letters are the initials for a negative ion. So anions are a negative ion. Now, something that's important to recognize is that anions and cations attract one another because they are oppositely charged. So a sodium ion will be attracted to a chloride ion and form the compound sodium chloride, which you might know as table salt. However, another way of thinking about this is that a sodium atom can transfer one electron to a chlorine atom. This results in the formation of a sodium ion, which has an overall +1 charge, and a chloride ion, which has an overall -1 charge. Now, these ions now have stable octets, so they don't want to react any further. However, we have a positive adjacent and negative, so they will get stuck to each other. So both the sodium and the chlorine obtain a stable electron configuration. However, they are now bonded to each other via an ionic bond. So there's a price to pay for getting this stable electron configuration. They now have to carry around this extra atom. So if we look at the periodic table, what we're going to see is that ionic compounds are formed by hydrogen in the metals that form cations combining with nonmetals that form anions. Okay, so this is an example problem from the book. It says a fluorine atom has 7 valence electrons. It has 7 outer electrons. Here it is here, all right? Then it says, do you think it is more likely for a fluorine atom to lose 7 electrons or gain 1 electron to obtain an octet? Write the formula of the resulting ion. So if fluorine with 9 electrons lost 7, then it would have the same electron configuration as helium, which is stable. Or alternatively, it could gain 1 electron, and then it would have 10 electrons like the noble gas neon, and it would also be stable. So when you think about it, it seems much more likely that fluorine will gain 1 electron than it will be for it to lose 7. So fluorine has 9 protons and 9 electrons. If it gains 1 electron, then it will now have 9 protons and 10 electrons, which will mean that it'll have an overall of 1 negative charge, and we can indicate that with a superscript minus sign. So I think that it is much more likely that fluorine will gain 1 electron rather than lose 7. And when it does, it will form the F- anion. So it's going to be easier to gain 1 electron rather than lose 7, and it'll form the F- anion. Okay, so that concludes section 3.1.